All right, so our next speaker doesn't need much introductions. Professor Geralt Siebert from the University of Bundeswehr is going to raise some awareness today and talk a little bit about the fundamental differences between laminated and laminated safety glass and how the interface between the interlayer and the glass is changing because of embedded PVs or because of coatings. So the floor is yours.
Yeah, thank you very much for this kind introduction. I welcome you all, and yeah, let's go. Okay, there's something moving, but the screen is nice. So first of all, I want to give you an overview about what's coming the next roughly 20 minutes. I start with an introduction, I end with a conclusion, and in between I will have some few words about regulations and give you some nice, colorful pictures about projects realized, tower in Munich, rehabilitation building, because sustainability is of course a key point, Cube, a new building, newly built building, and then photovoltaics as mentioned before. So starting with the introduction, of course I have to mention that the work I present is not only my work. I have a lot of helping heads and hands. Definitely we have the chair for structural design, which is my chair at the university. There's a lot of people involved, and there were a lot of people involved. This is what's named former in the lower line. There is a laboratory for structural engineering, which is shared by 3 chairs, chair for steel structures, chair for concrete, and my chair. And there's also a consulting engineer's office where things we think about in university are tested for the real world, that you can really also earn some money with. This is what we are thinking about. And you might ask why there are some names green. Well, all these persons are at the GPD this time. So, laboratory, well, our laboratory is a bit bigger. As you see, we have different equipment up to a press with a capability of 1,000 tons. The scalar field you see here is more or less history. By end of the year, we will get some better equipment, and this will be the future testing site for glass. We do a lot of testing in full-size samples, and if our laboratory is too small, we just go outside. There we have some more space to use. We have a tent with some containers where we can do full-size testing in elevated or reduced temperatures, so from -20 up to 80 degrees C, full size, several samples, parallel tested. We're talking about laminated glass, laminated safety glass, and of course, situation of broken is also interesting in different temperatures, and this was a slide just before COVID, or 2 of the 3 standing behind me already got a PhD. The third one is just before finishing it. A few words about material characterization. We do tests on the foil only by using, for example, the MTA machine, having this highly sophisticated equipment, doing the time temperature shift, getting a master curve, and then we look about whether this behavior of the foil only matches with the laminated situation where we have glass plus foil. So we do bending tests, creeping tests, torsion tests, also under different temperature levels to see whether everything is matching. Behavior of the foil itself, as you see here on the tension test, you see the stress over the strain curve, that is to say force over deflection more or less, and you see after a more or less linear begin, it goes to the nonlinear phase, and yeah, it's a slow testing, sorry for this. But we can just go to the next slide and see what's happening if we have glass plus foil. So this is fully tempered glass, broken situation, and you see the stiffness, of course, is a bit higher, or not only a bit, it's quite a lot higher. And as the deformations get bigger, of course, the shear strength or the part of the glass material gets lower, and the curves more or less connect again. Glass pieces fall off and no longer bring apart to the strength. And another question we just worked on was, is there influence of the interlayer on the breakage pattern? This is a laminate of two glasses, and you see in the broken situation, of course, there is this bending of the material of the broken glass because of the volume expansion. And as I said, the question is there any effect of the interlayer? And here again, we did some research. You can see glass panel, 360 by 1.1 meter, and a small detail here. There's a hole we are drilling with a simple drilling machine, and what is happening you can see on this spot here. So this is a high-speed camera, and we're looking about the breakage pattern. And yeah, there is a difference, to give you an answer on this, for different types of laminates. We see different behavior. If there would be perfect situation, there would be this 60-60-60-60 angel, but as you see in real world basalts cooling down, this 60-60-60 is not always, of course, the situation. It was a long introduction, yes, but I'll speed up, no worries. Regulations in Europe. In Germany, well, we have living in Europe, we have these harmonized conditions for the marketing of construction products, and in an annex there are the requirements given for construction works, which are completely matching with the Eurocode 0, so the basis of design. And you see all the blue marked spots 2 to 7, they are valid on the European level. What is still a national competence is number 1, mechanical resistance and stability. And this is a very important point to keep in mind. Well, sorry for this. Of course, you all know glass is a brittle material. Different aspects, in case a breakage occurs, have to be looked at. And instead of reading the text, we just look at a nice project. We see a church. And of course, it's interesting, if you're falling, you're not supposed to hurt yourself in the glass on the walking level. And if you're inside doing your prayers, you sure want to be safe sitting below the glass. And also, if you're sitting in this chapel, photo on the left-hand side, you expect the glass to be in position also in case it breaks. And these situations have to be designed, and in the Eurocode, which is coming on the horizon, there will be these fracture limit states and post-fracture limit states to be looked at. What you do, of course, you choose the correct material, tempered glass or laminated safety glass, preferred with big shards. And of course, interlayer again is of interest. This is well known. If you have fully tempered glass, there is no residual strength. If you have fully tempered with residual, with softer laminate, you have big deflections. If you have heat-strengthened glass with PVB, for example, you have a good behavior after breakage, so you can still open the door beneath this canopy and leave the building. And if you change the interlayer material, well, to more stiffer material, this also could work with fully tempered glass. So you just have to know what you're doing. The regulations on the European level for marketing of the products or for commercial distribution, they give a neutral, reproducible basis for doing tests. And there's one situation or one criteria for classifying a laminated glass to laminated safety glass. It has to reach minimum 3B3 for tests according to the DIN standard or the EN standard 12600. This is this pendulum test you do on the glass with a certain size on all 4 sides framed. So by doing this test, you can compare different materials, but a transfer to your real application might be a problem if there's different measurements, of course, if there's different fixing, like point fitting, like linear bearing only on the lower side, if you think about a balustrade, if you think about clamps. So, as I said, certification about test results of 12600 might be interesting, but for the real application, it doesn't help. For standard products, of course, test results, declaration of performance, and based on this, CE marking does exist. The question is what to do in real projects. Sometimes you need additional tests for design or regulated in design codes for an application of these products. And this is in national competence. And of course, if you have deviations of the standard products, then you also have to prove everything's safe. And that's where we start with the examples. So this is the HVB-Tower. It said it has a history, yeah. They started building in 1975, finished the building in 6 years, and since 2006, this is under heritage protection. So this is more or less like a listed monument. The original architects were Beetz architects, and rehabilitation work was done by Henn architects. And there was a lot of work carried out. As you can see here, or as you can assume, there will be coming a new facade. They will do a lot of other works, and the money they invest in rehabilitation of this building is around 250 million euro. So, of course, building in existing structures is not that uninteresting. What are they doing? They're setting up a new facade, double skin facade, with natural ventilation possible. So in the actual new situation, you can open the windows. If the window is closed, you have an airstream through the cavity that is not overheating, and if the window is open, fresh air comes into the building. This is just to get a short overview what is planned. The aluminum sheets, by the way, they are kept. So they put them out, clean them, and install them again. As I said, it's historical monument, so it has to appear the same after renovation. And as you can see here, depending on the lighting situation, there's a complete different situation. Here you have more or less black stripes. This is more or less like silver stripes. So depending on the lighting, depending on the sunshine, depending on the time of the day, looks different. And of course, coating processing changed since the 80s. And by this, of course, also the color changed. So we looked about whether there's a coating available which matches more or less. And the best small matching samples were put up. And then the guys from the authorities came and had a look at different types and different weather situations to pick out the the best fitting coating. And of course, this was not a standard coating, and the standard tests were not applicable. And in addition, the standard foil, which was basis of the contract, was, according to the information of the contractor, no longer possible to be used. So they had to switch and get more money, of course. We had to do a pendulum impact test because the parapet height was not high enough. So in case you open the window, the outer layer of the glass, the coated glass, has to be the anti-drop device. So we did a pendulum impact test to prove also this additional requirement. And the result was, of course, no dangerous fragments, adhesion is sufficient, no openings, glass stays in position, so everything's fine, and we can continue. This is an element we will look just 3 slides later. Fire protective glass. First, I want to show you how the elements look like in the installed situation. So the only difference to the situation before are these small holes in the outer facade. And all the other appearance is more or less perfectly the same. As I said, there are also a question about fire. Safety, there are staircases in the columns, there are elevators in the columns, and you have to reach them also in case of fire, safe. So that's why there is some fire glazing installed. Yeah, as usually thicker layers or several layers to guarantee the F90 requirements. And following the CE marking for the fire safe glazing, you usually don't have the declaration of safe breakage. It's not called a laminated safety glass, it's just laminated glass, because everybody knows, well, it's fine, but the person from the authorities, they want to have a statement on this. So you have, in this case, it was just an expert's report to also fulfill here the requirements. The Cube in Berlin, it's a newly built situation where again there is a lot of reflection depending on the time of the day, and the two pictures are made on a cloudy day. Architects from Copenhagen, 3XN. The facade, the outer facade, point fixed glazing, and because of this geometry we have a lot of different formats, and there was again a special coating of the glass which requires a special permit for laminated safety glass. And then you look at the sketches, you pick out the worst formats, and you do the testing, the small sample testing, and all full-size testing for the balustrades, because there are also some balcony in the situation, and also because of the inclination, overhead glazing tests had to be carried out. Everything was fine. And then there was this thing with the free edges. I'm an engineer. I wouldn't recognize that on this piece of glass there is a small piece of aluminum to protect the edges. But the architect, they do recognize this, and they don't want to have this. Maybe you see it at night, I don't know. Well, the requirement finally was free edges, and then the building authority said, okay, if you want to have free edges, we have to do additional tests under elevated temperature. So that's what we did. We did another tests for residual strength, putting them in the climatic chamber, heating up, and it behaved well, luckily. And also for the balustrade situation, we had to do the ball drop test first before the pendulum test. So we throw a steel ball on the edge of this balustrade element, got a crack, and after this we did a standard pendulum test. Luckily, it also went out positive. And that's the situation at the moment. So no edge protection, and you can see here a very perfect glass edge, if you can recognize it. Overhead glazing with PV, of course, everybody wants to use PV. At the moment, this is the design of a car park for charging electric vehicles, and unfortunately, the architect uses size of 1.4 by 2.5 meters. The span is 1.4 meters, so this is extending the maximum limit on the one hand side, and in addition, there are PV cells within the interlayer. So again, this does not match the regular CE marking. We had to do again residual strength tests according to the DIN 18008. So we hit the glass on 5 points near the corners and in the middle on both sides, top and bottom, under load, and look what's happening for 24 hours. And this is the breakage pattern after cleaning up. So you see heat strengthened glass, very well performed. And if we get samples in our laboratory, well, this is not really broken. So we do additional testing to see whether a cleaning standing on the glass would be possible. So this is a standard test you have to do. You have to throw the pendulum from a height, simulating that the person cleaning the glass just falls down, and of course it's supposed to stay in the situation. Because this glass was already broken before, due to the residual strength test. It did not survive. It might have survived if it would have been new samples, but the customer didn't want to pay for it. We had our fun, and some more information about the adhesion situation, about the situation if the glass breaks really to small pieces, whether everything is fine or not. So I said I will speed up, so 14 seconds for the conclusion. CE-marked products, of course, they follow the European regulations, show performance, but only for the declared essential characteristics. And this is really a key point. Sometimes not all characteristics are declared, and you have to watch very carefully. Level of performance for safety and accessibility in use, which is valid for whole Europe, is a different level, a lower level than mechanical resistance and stability. This you have to keep in mind. There are, for the installation, for the application, national requirements to be looked at, and if there's something special going on, you have to do sometimes tests. Also, if glass elements are regarded as non-structural, there might be high potential of in case of damage, high potential of damage in case of euros, dollars, and lives. And with this, I would like to thank you all for your attention. Nice view of the Baltic Sea. Thank you very much.